All right, so let's check this out here. We got Kansas in the house, and they're going to be traveling at 85 kilometers per hour. And another train's going to be leaving at the same time, traveling in the opposite direction, south, at 95 kilometers per hour. The question is, how long will it take before they are 315 kilometers apart? Cool. So a lot of these kind of problems, these motion problems, we're going to be using distance equals rate multiplied by time, also known as DIRT. So we'll be using that. And this one right here, I put this is a motion in opposite directions, because a lot of these problems, they just follow the same type of pattern here. And so anytime that you have two objects that are moving in opposite directions, as I have right here in my little subtitle, they're actually going to behave in the same way. So pretty much you can use this as a model for like other problems. And just so that we have like a little graphic, so say if they start here, one's traveling one way, one's traveling the other way right here. So, and we want to know when are they both going to be 315 kilometers apart. That's the goal, is that one's traveling in one direction and the other in the other direction. So when are they going to be at the same basically when are they going to be 315 kilometers per kilometers apart. So what we're going to do here is that we're going to use a little chart here to kind of just organize our data. So I'm just going to throw down some vertical lines, throw down some horizontal lines right there. All right, so how about we're going to just use this right here, distance equals rate times time. So distance equals rate multiplied by time. So this is going to be my distances, this is my rate, and this is my time. So we're just going to say that these guys are going south right here, and these guys right here are going to be going north. Actually, I'll probably switch those just so that we kind of stay consistent here with the problems first. So these guys will be going north, and these guys are going to be going south. So let's just see what information can we fill in right here. So we do know that we're traveling at 85 kilometers per hour, the person that's going north. So we know that that's going to be our rate of 85 kilometers per hour. Now we don't know the time. It didn't tell us how much time there, and actually that's what the question is, how long. So I'm actually just going to put a T right there. So check that out. We'll see how this is going to work. Go to the second one now. Now the other train leaves at the same time, traveling south 95 kilometers per hour. So I'm going to put 95 right here, and their time is also going to be T, because we don't know what it is. So check this out. We have the distance equals 85 times T, and the distance equals 95 times T. See if this would make sense right here. Say if I call this guy D1 and distance 2. Wouldn't it make sense that maybe we can make this guy right here D1, this is the person going north, and this is going to be our distance 2. So check this out. That means I'm going to add my distance of D1 and my distance of D2, and collectively, if I take their sum, that better be equal to 315 kilometers, because collectively that's what it should be. So I can actually create a mathematical equation, D1 plus D2 equals 315. And this is the way that you always do opposite direction problems. You take the first distance plus the second distance, because they're always going to go in opposite directions, and you set that equal to the total distance. So you want me to make a little note of that. You will always do that for opposite direction motion problems. If they're in opposite directions, you add their distances, and it's equal to the total sum. So D1 is 85t, so 85t, and D2 is 95t, and that equals 315. Alright, so now this just becomes a matter of us just solving our algebraic equations. So 95, 85, what's that? It's going to be 180 t equals 315, and so that means our t, which stands for time, is 1.75. Now we don't want to just stop there, because we got to give some context to the problem. This is why anytime that you have a word problem, you want to say, okay, we want to make sense of this. What does this mean right here? Okay, well, the question was, how long will it take before they are 315 kilometers apart? And so since we're in hours, this right here would mean 1.75 hours. Now, you normally don't say, oh, it's going to take me 1.75 hours. Normally, the way that you would say this is going to say 1 hour and 45 minutes. And let me write that a little better there. So we would say 1 hour and 45 minutes. And I got 45 minutes because if we break our clock into hours, right, 12, 3, 6, and 9. So the first quarter is 3. The first quarter is 15 minutes. Second quarter is 30 minutes. The third quarter is 45 minutes. And then like an hour. So that's why 75, a 75th of an hour is going to be at 45 minutes, which is how I got that right there. So our answer is really 1 hour and 45 minutes. Or if you want to say 1.75 hours, that's going to be fine right there as well.